टेक्नोलॉजी ना जब भी आती है तो लोगों की फट जाती है।
Basic programming is going to be as important of a skill.
भारत के युवा पढ़ाई के साथ ही स्किल में भी उतने ही दक्ष हों।
Hello friends, welcome back to Skill Raptor. This is your host Atharva. Today we are going to discuss a very interesting topic in probability, that is binomial probability distribution. And while doing that, we will be looking into the concepts of binomial distribution. Then there are two applications which I have identified. That is, one is regarding a pandemic patients, another is managing a e-commerce supply chain. And before I go ahead, I will definitely like to request you that please kindly like, share, and subscribe to my channel, and also recommend it to your friends if you find it useful. With that, let's move on to our first topic, that is how to identify a binomial probability distributions. So see, now it's very simple. The binomial distributions are generally having only two outcomes, that is, one is either success or failure. See, for example, if you toss a coin, so if I say that head is a success and tails is a failure, and head is success and tails is failure, so this is the outcome which we are looking at. So it can be a success or a failure, or it can be curable disease or a non-curable disease, like that. So there are only two possibilities of the outcome which we are trying to understand. Then the next is the trials of a binomial probability should be finite, and definitely they should be a discrete variable, that is the outcome should be in whole numbers, that is 1 2 3 4 5. It cannot be 1.5 2.8, so it should be discrete. And definitely when you toss a coin, the experiments are independent to each other. Every coin toss is independent to each other, and it is also identical. So these are the traits of a binomial probability distribution. Most important one to remember is that the binomial probability, as the name suggests, is concentrated on only two outcomes. Either it can be a success or a failure. Now let's try to understand how it works. Now this is a simple application example which I have taken to make you understand how it works. Now say if there is a 60% chance that a COVID patients can be cured, say for example. Now if there are 4 patients who are identified with the symptoms and they are being treated, so what's the probability that exactly 2 will be cured? Say the 4 patients are A, B, C and D, and to get exactly 2 cured, there will be 6 cases. So case number 1 is either A, B will be cured and C and D are not cured. Case number 2 is A and C are cured, whereas B and D are not cured. Similarly, there are 6 such cases, and probability of getting cured is 60%, that is 0.6. So C means cured and NC means not cured. So I will just subtract it out of 0.6, so it becomes 0.4. So curing probability is 0.6 and not curing probability is 0.4. Now how do we arrive to our conclusion? Because the question we have asked is what's the probability that exact 2 can be cured, and this analysis is to find that probability. So we are taking 6 cases where 2 patients will be cured. So for case 1, the probability of A curing is 0.6 into 0.6 into 0.4, for C not curing and again 0.4. Or similarly, C2 will be 0.6 into not cure is 0.4 into 0.6 into 0.4. Now you will see that the same phenomena repeats till C6. A common observation is almost every case is zero point 0.6 square into 0.4 square, because we are talking about exactly 2 being cured, and you will be able to understand why I have taken this number 2, because it is making our calculation easy. This is because this is to understand. So there are 6 number of cases. So I am multiplying it by 0.6 square into 0.4 square. Now you may want to find this answer. 6 into 0.6 square into 0.4 square, you will get some answer there. Now uh, this is the analytical solution for the binomial probability distribution. But what will happen if I say that there are 100 patients, and what's the probability that exactly 5 will be cured? Now see, our task will become difficult. Now you cannot have A, B, C, D till 100 letters. So here it will be 100 columns and 5 to get cured. So there will be like 100 C5 cases if I take that kind of example. So it will be a huge number. So it's practically impossible to find the analytical solution. So we will have to convert it into a converged solution or a concise solution. Now let us see how to do that. Now for the same scenario of 4 patients, I am taking different cases. For example, 0 patients cured, then 1 patient cured, 2, 3 and 4. So what will be the probability for 0 patients cured? There will be only one such case where only 0 patients are cured out of 4. So 1 into 0.6, sorry, nobody is cured means 0.4 to the power 4. Then for 1 patient cured, it will be 4 into 0.6 into 0.4 cube. Then for 2 patients cured, we have just found out 0.6 square into 0.4 square. Then 3 patients cured. So there will be 4 such cases if you do the analytical method, which we have done in the last slide. 0.6 cube into 0.4, and 4 patient cured, all are cured. Definitely there is only one such case, so I will write 0.6 to the power 4. Now we will try to analyze it or converge it into a single solution. Now see, the number of cases are given by NCR somewhere. So R is the favorable case which we are looking for, which is curing of a patient. So probability that R patient gets cured can be given by total number of patients out of which we are looking, that is 4 here, then into probability that patient is cured, that is to the power R, and patient and Q, that is probability that patient is not cured, is n minus R. So that is the working formula which the binomial distributions, when we are solving, this will be used. And let us learn with a e-commerce exciting example in a e-commerce industry how to apply this formula. Now it's a very simple problem. Now let's say 12% of items shipped by e-commerce. Now you might have seen that there are many e-commerce websites where whenever they ship their items, there is a defect found in that item, or that item is not being shipped properly, there is a damage like that. So let's say that 12% of items shipped by an e-commerce website are defective. It is the average which they have found. Now say if there are 20 items to be shipped which are ready to be shipped, then we have to find out what's the probability that 5 items are defective. Now just I will help you learn how to apply this formula, that is probability of R NCR into probability of success, that is P to the power R Q n minus R. Now here R is 5, so P of 5 I will write. Then P, that is probability of success. Here let's say it is not success, the P is the probability of defects which is given, that is 0.12%. So Q is 0.88, and we have 20 items which has to be shipped. So 20 C 5, N is equal to 20, P is 0.12 to the power 5 into Q, that is 0.88 to the power n minus R, that is n is 20 and R is 5. So 20 minus 5 will give you 15. So if you solve this, you get answer 0.054. So that is the probability which we have found out, that there is a 5.4% chance that out of 20 items which are shipped, 5 items may be defective if the average 12% of items shipped by that company website are defective. So that's how it can help you to judge the quality of the supply chain, and this analysis can actually help you improve the inventory as well. If there are 5 items shipped which have a 5% probability of having damage, then you may accordingly plan to keep the replaced items. So that's all for today's lecture, friends. I think if you liked it, please kindly like, share and subscribe. Let's meet again. Thank you very much. Bye.